Good afternoon, everyone. My name is Nick Dean, and I'm here to present Airline. I am a graduate mechanical engineering student here at UMass Lowell. My associates include Daniel Gerfink, who's also from the engineering department, and Patrick Pang from exercise physiology, but today I'll be doing the presentation. So what's the problem? Currently, over 1/3 of Americans are suffering from poor posture. This can lead to problems such as compressed disc, sciatic nerve impingement, chronic back pain, and arthritis in later age. And it also affects our health and overall appearance. Poor posture can actually affect your confidence, which is a little known fact, and can be noticeable in the workplace. Currently on the market, there are no devices that both passively and actively correct posture simultaneously. So that leaves this opportunity. The market for posture treatment alone is $85 billion in the United States. But this isn't spent for proactive treatment, this is spent, sadly, for reactive treatment. Essentially, the only way to fix poor posture in older age is through physical therapy, invasive surgeries, and other expensive medical procedures. What our goal is to present our product to physical therapists and chiropractors with a questionnaire to essentially get their feedback and essentially have them market our product. When I've gone to physical therapy in the past, when they recommend a product, they just don't recommend the device, they'll even recommend the company that they want you to look at. So our goal is to use them as our sales folks for our target market, the baby boomers, the largest, wealthiest generation that is more apt to spend money on medical devices such as these. Our product will cost approximately $100 per unit, and each product will be sold at a premium with a price tag of $249.99. Bring us to our solution. A posture correction suit that not only detects improper posture, but also actively corrects it, and then releases you so that you're not stuck in this pose the entire time. Airline works actively whether the user is sitting or standing or walking, and trains the wearer by providing physical support, but only when it is needed and detected. Our competitor products include Lumo Lift and Upright Go. These are passive devices. Upright Go sells for approximately $80 on Amazon, Lumo Lift for $200. They are essentially gyroscopic sensors that stick to the back and detect slouching, and then it sends a notification to your phone via an app and vibrates as well. Our other competitor products would be other various harnesses that go by several names. These are adjustable straps that you have to manually adjust that will keep the head up and the shoulders back. Our product will combine both of these benefits and do so automatically using soft robotics. Our funding usage is to develop and patent a system that detects poor posture and can visually display the spine curvature via a smartphone app. We will use this to develop a patent an auto-adjusting elastic system that will correct posture in conjunction with the sensors. And we will also need materials for continued R&D and prototyping. And I've included a picture of what we'd like the app to look like, showing the several sections of the spine, as well as showing the different degrees of curvature. Last semester, we developed a prototype that used compressed air that would use a solenoid valve to correct the posture, but we're actually moving more towards auto-tensioning elastic straps that can bring the shoulders back instead of using disposable aluminum compressed air cylinders. Thank you. Do we have any questions?
Is this regulated by the FDA?
So our goal is to get a Class 1 exemption. So 35% of devices on the medical device market are Class 1, but 93% of those tend to get the pre-market exemption. So we think that we'll be applicable for this, since most of these other products are not, our competitor products aren't FDA approved, because they're not invasive enough where they would require.
Yours has, you create energy to make the movements, right? So that may bring you to a higher.
It's going to be like, if there's any correction, it's going to be so little that it's not so much a correction as it is just assisting or helping. So you would still have to sit upright, but it's just going to give you just enough tension to pull the shoulders back. It wouldn't be much different than if you just manually just pulled the straps on a manual device and really, torqued yourself over. But yep, that's a good question. But our goal is so that we don't have to submit a 510K and have to go through that Class 1 process.
Hey, can you just double click again a little bit on the difference between, like, I know Lumo Lift because they spam my Instagram feed, and they like seem to be pushing hard. And I get the idea of, like, you do this and your phone goes off. We're just a little bit confused as to what your differentiator is to that approach, because you talked about an app and you talked about a couple things, so.
Yep, so our device is going to basically, it'll show you not just like that you need to sit upright and correct your posture. We are actually using small strain sensors that span the whole curvature of the spine. So this will actually ideally be able to show you like where like the certain compressions and curvatures and the problems are specifically.
So much more targeted.
So it's much more targeted. That's just on the app end.
Okay.
We also developed a device, and it's in my bonus slides.
Yeah.
So this is our product. I can see if I can try to get it to work. So this was our old device that used compressed air. And essentially it works similar to Lumo Lift, where we tilt a gyroscopic sensor. So you can see here, he tilts the gyroscopic sensor and then opens the solenoid, filling the bladder with air. But we have to use these little disposable, or they're actually recyclable aluminum compressed air cartridges, and we're foreseeing a lot of issues with that and trying to get that approved and trying to market this device where, hey, you gotta keep buying all these replacement air canisters every day. So, sorry about that.
That's okay.
So, yeah, that's how we wanted to move towards a more elastic strap approach. The idea is to use smart materials, smart elastics that can actually, they stiffen as you stretch them, so they just won't even let you stretch past a certain point, and then you wouldn't even have to have motors or anything like that to regulate the tension in the straps.
And that's good, you won't have to have a pump.
Yeah, you won't have to.
Which is the other option, and that's commonly used with some other types of devices I'm familiar with.
Yeah, if we had to go with a pump, we definitely need a class 1 at least, possibly even a class 2.
Have you thought about, like you mentioned physical therapists, have you thought about reaching out to, certified personal trainers, places like that? Because, so weekly I go see a mobility coach, just because I still do some competition work. And, there are devices there that they're pushing all the time.
Yeah, we actually did consider that, but it wasn't our original plan. We were looking more at physical therapists and chiropractors because that's what I have experience with my posture issues. So I was just looking more at my own personal experience. But that is a good idea. That is something we've discussed, is looking at personal trainers and getting them to take our questionnaire and recommend what they would want to see in a device as well.
And so your end user customer, you first said was baby boomers.
They're going to be our target market just because they are more apt to buy a product like this. You're typically not going to see a millennial spending $250 on a corrective medical device. So that's why we want to originally target them and then try to move our way down to the other markets.
What's the price point on the gyroscopic sensor of your competitors?
So the Upright Go,
Yeah.
the sensor that they sell at market is $80. It's $79.99. What we did with our gyroscopic sensor, it was an Arduino like PLC device that you can just build at home, and the main motherboard cost $20, and then the gyroscopic sensor was $10. So this cost $30 total to build. So it's a very, very simple device, and it's pretty easy to code as well. So yeah, that's why their devices are very simple, and that's why it's easier for them to make more money. But they've gotten poor reviews because it doesn't stick very well, and people seem to want more from it as a product for what they're paying for. Especially Lumo Lift, which is basically a Fitbit that does what Upright Go is, but they charge $200 for it, and that's why they have a 3.5 rating on Amazon.
Have you considered adding additional sensors, like maybe respiratory sensor or accelerometer for if somebody falls? Or
so the gyroscopic sensor is an accelerometer. That's how it detects that change in posture. And it works on 9 axes, but we were just looking at one just to get the bag to inflate. But yeah, we were looking at gyroscopic sensors. We're now looking at strain sensors that go along the spine, but we have not looked into respiratory sensors or any of those devices.
what's the final material going to be of the actual harness? Have you worked that out yet, or?
Of the elastics, or of the actual just vest that you wear?
The vest.
We're looking at Lycra. It's what's basically used to make yoga pants and a lot of athletic materials. We actually, for our original prototype, that's being worn by Patrick in this picture. It looks like a bulletproof vest, but we just had to quickly put something together for the prototyping challenge. This is all made from Lycra. It's all recycled material that we got from New Balance and some other companies.
Have you done any work with the Fabric Discovery Center here on campus?
Yes, actually, this vest, we were assisted by Diana, and she basically helped us put this initial test vest together, and she'll hopefully be assisting us with our next iteration this semester.
And again, coming up with your price point, did you look at any other sort of potential comparables here? Versadesk, some of the other approaches, maybe a bit removed from.
Yeah, I use one of those adjustable standing desks. It's one of the knockoff ones.
Yeah.
They do work well, but you have to know that you have to alternate sitting and standing with them, or else you'll get blood pooling in your ankles and your knees. So there's issues associated with that. When I bought that desk, I also had to buy this like $100 contoured map so I could change my feet positions to also help the blood circulation. So those are good solutions, but I think we could be doing a lot better for workplace ergonomics, and a lot of companies are starting to pay more attention to this.
Because I think my desk was like $250, and then you add the pad on the floor, which is like $100, and you got $350
Right there, exactly.
Right there. So.
Not including if you bought, another posture corrector or anything to remind you on top of that. So the costs are just going to add up for these little devices that only address one specific area instead of a whole problem.
Nick, have you thought about, you said you think it's going to cost about $100 to manufacture.
Yep,
right?
so
and $250 to sell it.
Going back to our budget, our prototyping total last semester was $470. This was purchasing micro. This was when we had to build a plumbing system and purchase all these micro components. That's why we wanted to eliminate the whole air system entirely, because it was just so expensive and it wouldn't be cost effective, especially when we had to mass produce. But we think with the just like simple elastic straps and just the vest portion, we could even get it below $100 per unit, well below.
Yeah, so my question was, you talked about the 100, and is it, with the straps and the adjustability, do you anticipate sort of a one-size-fits-all approach to the harness itself, or do you think you're going to have a different body type versions, like small, medium, large, extra large, and you think will that affect ultimately your cost of production?
I think originally we wanted to go with a one-size-fits-all, just because that would be the easiest to start with. It wouldn't make sense for us to try to tackle too many sizes at one time. So we would just have to rely on adjustable straps just to hold everything on. The straps that we used on our old prototype are cotton elastic, so they're stretchy, and then they just Velcro together. So it's pretty simple design. You don't even need buckles.
Thank you.
Yeah. No problem, gentlemen. Thank you so much.
Thank you very much.
Thank you. Should I just leave this here?
Yeah.
Great sporting detail.
Anytime. Thank you.